the species that explores, that fashions vessels to carry us into the unknown. We sailed the planet of our birth, saw its wonders, and made it home. And it wasn't enough. We built flying machines to explore higher, faster, farther. Heroes flew them beyond what once seemed possible. And it wasn't enough. In time, we created special craft that would ferry us to the edge of space and back. And as always, there were the few, brave and brilliant souls, ready to guide this vessel through dangers in the name of discovery.
TTCs go. SRO. SROs go. You have a range clear launch. Range engine start.
Using the Space Shuttle, we built an unprecedented outpost in the heavens. We learned in the weightless world of the International Space Station, peered into the dark night of an infinite universe, and it wasn't enough. Now we are fashioning vessels to set off on our greatest adventure of exploration ever, to Mars and beyond. Who knew that 30 years would go by so quickly? That these unique spacecraft would leave in their wake a public captivated by their achievements. A planet poised at the brink of deep space exploration.
As an astronaut, I definitely felt I was saying goodbye to a longtime friend when the last shuttle landed. My name is Chris Ferguson. I was lucky enough to fly on 3 shuttle missions, one of them on Endeavour. So it's no surprise that I wanted to be there when she was headed for her new home at the California Science Center in Los Angeles. From the look of it, you might think it took as much engineering to get Endeavour through the streets of LA as launching her into orbit. Watching the orbiter squeeze through the city neighborhoods, you could feel just how much the shuttle had come to stand for, almost as if it had taken all of us into space. I sure don't want the world to forget this remarkable spacecraft and those who built it and the legacy they left, lighting the way toward our next frontier in space. The shuttle was the first reusable piloted spacecraft. and its engineering and software was so bulletproof it could be flown by computers less powerful than today's smartphones.
200. 100.
At 235 miles per hour, the shuttle had the fastest touchdown speed of any flying vehicle ever built. When you glide 220,000 pounds of spacecraft to a no-power landing, the gear hits with a major whomp.
Touchdown.
Conceived in the 1970s as a kind of wing delivery truck to build a United States low Earth orbit space station,
Give you a payload ID of 1.
the shuttle actually flew more than a decade beyond original expectations. It was the shuttle program that allowed us to do real ongoing work in space, to put delicate equipment into orbit, and to retrieve and fix that equipment when things went wrong. Orbiters deployed, retrieved, and repaired over 100 scientific and communications satellites. And no missions were more important to our understanding of deep space than the 5 flights, beginning in 1993, made to repair and upgrade the Hubble Space Telescope.
Hubble affirmative. You have a go for release.
I think history will view the Hubble Space Telescope as one of the crowning achievements in astronomy. The Hubble gave us an unprecedented view of both our closest neighbors and of galaxies unimaginably far from our own. Further space telescope investigations have revealed that the number of Earth-like planets capable of harboring liquid water is vastly greater than scientists once calculated. In 1995, the shuttles began a new era of international space exploration when Atlantis docked for the first time with the Russian Mir station.
10.07, 106, 4 inches. Now we have captured space.
Altogether, the orbiters made 11 trips to visit Mir. These missions established a level of international cooperation and expertise that continues to this day. Though Mir no longer orbits Earth, the shuttle proved itself as a brilliant reusable tool that allowed us to live, build, and do science in the weightless environment of space. the shuttle's truest legacy crosses the sky above us every 90 minutes. The International Space Station could never have been built without the shuttle's payload and spacewalk capabilities. Space shuttles and Russian Soyuz and Proton rockets made more than 40 flights to construct the International Space Station, a true engineering miracle. All three of my orbiter missions were to the ISS.
Modules built by NASA partners in Asia, Europe, and North America came together above Earth over a period of 13 years to create a floating world longer than a football field and with more living space than a 6-bedroom house. A typical ISS mission requires an astronaut to live 6 months on board. But some crew members will spend a year learning even more about the very real physical and psychological stresses of long-term separation from Earth.
These missions and the 15 nations that designed, built, and crewed the ISS forever changed space exploration into a cooperative international program and made a true home and science lab like no other.
Wash away my troubles, wash away my pain, wet the rain and shine by love.
ISS system designs and scientific experiments have spawned a multitude of Earth-useful discoveries, including breakthroughs in water purification and robotic microsurgery. But most important, the ISS is our springboard to the future, giving us the knowledge and confidence to sustain human life as we explore deep space.
Everyone is helpful, everyone is kind.
Life on ISS is all about getting the job done and having a little fun.
Everyone is lucky, everyone is so kind. On the road and shine by life.
And nationality is mostly about tasting each other's food.
Yeah, 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 yeah. Oh, yeah, yeah.
Through 3 decades of camaraderie and dedication, 355 people rode the shuttle into history. They circled the Earth 21,000 times, and it all came to seem routine. Until it wasn't.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
This shuttle mission will launch. My God, there's been an explosion.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
In 2 accidents that stunned the world, we lost 14 astronauts. It was a sobering reminder that every spaceflight is charged with potential danger.
They had a hunger to explore the universe and discover its truths. They wished to serve, and they did. They were pioneers. The future doesn't belong to the faint-hearted. It belongs to the brave.
The world mourned, but pushed on, because the accomplishments of the Space Shuttle and the International Space Station were full of life-changing promise. In memory of our lost heroes, the global space community pulled together to reignite the future of both programs.
Who could ask for a better ending to my career as an astronaut than getting to fly the last shuttle mission on Atlantis and a final visit to the ISS?
Atlantis, go.
So for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, have a little fun up there.
Without ending the journey today, Mike, we're completing a chapter of a journey that will never end. You and the thousands of men and women who gave their hearts, souls, and their lives for the cause of exploration have rewritten history. Let's light this fire one more time, Mike.
Though the shuttles no longer fly, I never miss a chance to see Atlantis at the Kennedy Space Center. But I came to KSC to get a look at the next big step in deep space exploration, and it's called Orion. Here, in the giant operations and checkout clean room, the new Orion multi-purposed crew vehicle is coming together. What an impressive vehicle. Look at that. It's beautiful. Oh, it's gorgeous. I'd love to climb in there. Orion is a true deep space exploration craft designed to carry astronauts of the future back to the moon, to asteroids, and even to Mars.
I've always been drawn to explore and try new experiences. Maybe that's why I applied to be an astronaut. I'm Serena Anand, and I'm one of the newer group of astronauts chosen by NASA.
Like the rest of my class, I'm absolutely honored and humbled to be here, and it's great to be a part of this team.
I guess you could say I'm one of those people for whom the future has always seemed an unfolding adventure.
So you can go forward and backwards in the procedure just by using this toggle switch over here.
Yes, that exactly.
Learning from astronauts like Lee Morin, who have already spent weeks in space, gives you a great sense of confidence.
The Orion mock-up provides astronauts in training, like Serena, a chance to learn flight procedures and also give feedback to perfect new systems. This should be a piece of cake for Serena, since my shuttle's 10 screens and more than 1,000 switches have been streamlined to just 3 screens and 60 switches on Orion. Hey Lee, you can open the helium crossfeed valve?
Okay, we got that go, so go ahead and send that command on the helium crossfeed valve.
All right, copy that.
And the shuttle's 100 pounds of flight manuals and checklists have been reduced to, well, 0, since Orions are all on computer. Stand by and we'll evaluate. But even with all these improvements, to get Orion into deep space, we're gonna need a bigger rocket.
When NASA's giant space launch system built by Boeing is complete, the rocket will stand as tall as a 38-story building and make more than 9 million pounds of thrust, enough to lift 22 elephants into space. For deep space expeditions, the SLS will need to lift 5 key mission components beyond low Earth orbit. Since Orion is too cramped for a 6-month journey to Mars, one solution being developed is an inflatable habitat to house the crew en route. A solar electric propulsion device will provide continuous power for the round-trip journey. A lander craft will carry the crew from their orbit above Mars down to the planet's surface. Months later, an ascent vehicle will lift the crew back up to the orbiting Orion for the return trip to Earth. But even using the most sophisticated future spacecraft, a 2.5-year round-trip journey to Mars will present new challenges to the human body.
I wanted to thank the Indiana State Museum for having me here. It is an absolute pleasure.
As a medical doctor with a specialty in aerospace medicine, I am particularly interested in keeping astronauts healthy as we head into deep space for long periods of time. Our experience with more extended weightlessness on the ISS has shown us that the human body will face challenges during lengthy journeys to deep space. Key issues are muscle and bone loss, which can start after just a few days of weightlessness, along with degrading of vision for some astronauts. We now know that exercise is the antidote for most problems caused by weightlessness. And I mean exercise, about 2 hours a day. But even so, the first explorers to Mars will need to rest at least a few days after landing on the planet to readjust to walking, though Mars has less than 40% of Earth's gravity. Radiation is another risk in deep space. Radiation from our sun's solar storms is one source of danger. But cosmic radiation, which permeates all of deep space, is another ever-present challenge to human health. Sections of Orion, as well as the transit habitat, will have to serve as a shelter in the case of a major solar flare.
In the Arizona desert, an Orion mock-up is being drop-tested to evaluate re-entry systems. On returning from deep space, Orion will enter our atmosphere more than 50% faster than shuttles or Soyuz capsules, and generate 5 times more heat. So perfecting her parachute deployment and heat shield is key to crew survival. At the Kennedy Space Center, Orion is being prepped for an uncrewed test flight into deep space. This new vessel marks the first step in over 40 years to put humans beyond low Earth orbit. A journey to Mars is on the horizon because of wide-ranging international efforts by both governments and private enterprise. Companies from Boeing and Lockheed to newcomers like SpaceX, Sierra Nevada, and Orbital Sciences are developing spacecraft to service the ISS and beyond. Some private groups foresee a technically simpler one-way mission to colonize Mars. Already thousands have volunteered to live permanently on the red planet. The demands of going to deep space will push old designs to new limits.
This looks good.
Hey, new glove. Should be good.
Sounds good.
My name is Lindsay Aitchison, and I am a spacesuit project engineer at NASA Johnson Space Center. I first started thinking about spaceflight when I was 4 years old, when I first came to JSC to take a tour at the visitor center. We have pictures of me just sitting inside this spacesuit, and I just knew that's what I wanted to do. When the Apollo suits were first done, those were very short duration EVAs. We didn't have a lot of mobility in that suit, so when you see those astronauts hopping around on the lunar surface, it's not because they themselves are clumsy or that the gravity is just impossible to deal with. We didn't give them enough mobility in the suits, so we learned a lot from that. For the next generation suit, there's still a lot that we don't know about what it's going to be like to live and work on Mars every day. Once there, you'll be doing EVA, walking outside on the planet about every other day. Once we have the hardware in-house, we become the experts of how that hardware works, what it does, and how it meets the needs for our next phase of our mission design. We actually get into the suits because the best way to understand how a spacesuit moves is to be inside of it and work it yourself. I'll be asking Richard to perform specific tasks, and what I'm looking at is, what is his gait like? And so I'm watching how the bearings in the hip move and how the bearings in the waist move. And by comparing natural body motion to suited body motion, we can start to tweak the design of the suit to make it more natural. So that's what we're focusing on for exploration, is how do you walk, how do you bend, how do you kneel, how do you do all those geology type tasks? So one of the big problems they had in Apollo was all of that dust on the lunar surface. It's stuck to everything. When the guys would come back inside of the lunar module at the end of their EVAs, taking off their suits, there was dirt everywhere. There was dirt on themselves. It was just gross, right? And that dirt is actually pretty harmful, the lunar dirt, specifically to breathe in for long periods of time. So long duration missions, we wouldn't want to bring that dirt inside with us all the time.
All right, Richard, nice job. Time to come on in.
So one of the key concepts we're looking at for lunar and even Martian missions is using what we call a suit port. The idea of a suit port is that you have this plate that becomes your pressure seal between the vehicle and your suit. So when you're not using the suit, it stays outside the entire time. It is physically attached to the vehicle, so you can come in and out of your spacesuit without ever having to physically go into an airlock like we do today.
Welcome home, Richard. How'd the suit feel?
Feels good.
Outstanding. Strong work out there.
Driving a space exploration vehicle on dry land is great training for deep space missions of the future. But driving a mini-sub was even more exacting. No, there are no liquid oceans on Mars. But before setting out for the Red Planet, astronauts may make test missions to nearby asteroids. A mini-sub resembles the kind of craft we will use to explore asteroids. In the ocean, matches the zero gravity of space. This Nemo 16 mission marks the 16th time NASA has trained at the Aquarius Lab, which is anchored 60 feet underwater off Key Largo in Florida. NASA aquanauts live in the lab for up to 2 weeks without coming to the surface. This allows us to work the entire day and only decompress once at the end of the mission. Any mistakes here can have real consequences, exactly as in deep, inhospitable space. Since asteroids appear to have changed very little since they first formed, they could tell us a lot about our early solar system. Ultimately, we may develop space tools to capture and reposition a small asteroid to orbit our moon. This would allow for easier study and also develop our ability to deflect a larger asteroid that was on a collision course with Earth.
This Olympus inflatable habitat, designed by Bigelow Aerospace, is a look at the future of living in space.
Jay, this is amazing. How big is that?
Thanks. Yeah, it's really big. It's about 2,250 cubic meters interior volume, which is a little over twice the size of the International Space Station.
And it looks like it's like 40 feet tall or something.
Yeah, it's probably 45 or 50. It's really big.
And once you get into space, you just inflate it with air?
Right. We bring up huge compressed air tanks that bring up large volumes of air. And this thing expands out, so the inside is about 16 meters in diameter, and the outside's a lot bigger than that.
It's surprising that an inflatable habitat can protect its crew against micrometeorites and radiation, but that's what tests have shown. The immense volume of Olympus will provide ample work areas, as well as living space to help maintain crew morale.
Supply craft to provide food, fuel, and radiation-protective living space will be landed on Mars well before the first human expedition is launched. We don't know exactly what all the spacecraft will look like, but concepts are under active development. Our infatuation with space exploration is as limitless as space itself. Without the shuttle, there would be no International Space Station, the vital test bed for a future human expedition to Mars. And that mission is closer than you might imagine. NASA projects we will get to Mars in the 2030s. In other words, within the career of today's young astronauts.
So any of these movies that you see where people survive even for 20 seconds, Operation...
Why go to Mars? Why not just send more and more sophisticated robotic vehicles? I think to explore beyond what is known is simply at the core of our DNA. And only a human mission can tell us definitively if we can survive and establish future settlements on Mars. Astronauts exploring the planet may notice and learn things robots could not. Things that could help take us to the next frontiers beyond Mars. Every 26 months, there is an optimal window for launching spacecraft to Mars. But even using the planet's orbits to shorten distance and increase speed, with currently planned propulsion, the trip to and from Mars will take 6 months each way. Someday, even more exotic plasma or fusion propulsion could shorten the journey. But the first explorers to Mars will not have that luxury. Orion can transport up to 6 passengers, but for a first trip to Mars, it would likely carry no more than 4. While going to and from the Red Planet, Orion and the inflatable habitat will be the astronauts' life support home for flight control, science, and that all-important physical exercise. Going to Mars, getting there, working there, coming back, will take nearly 3 years. I wonder how that will feel, to be away from home and friends and family for so long. There is no 911 in space. When Orion nears Mars, the spacecraft is 2 years away from any possibility of help from Earth. Even radio communications will take 40 minutes to send and receive, so any equipment failures or other emergencies must be solved by the crew alone. Nearly 4 decades of robotic exploration on Mars has blazed a path for humans to follow. Craft like Pathfinder and Curiosity. Maybe I'll get to kick the dust off their tires. Though it will be incredibly exciting to land on Mars, our ongoing training in sophisticated simulator labs means it won't feel entirely unfamiliar when we get there. Later explorers to Mars might travel hundreds of kilometers to mine their own water and hydrogen to make fuel for their return to Earth. But first visitors will have their hands full, making the discoveries that only a human mission can accomplish. I don't know if I'll ever get to walk and work on Mars, but I may already know some of those who will. Someone who dreams of it, just like me.
Humankind has forever been drawn toward the unknown by the simple innate conviction that to see the long-hidden side of the mountain, to brush the infinite depth of the sea, might reveal where we come from and who we are. When humans do touch and explore Mars, it will be among the greatest achievements in history. But even that won't be enough. We are the species that explores. We will fashion new vessels to carry us still deeper into space, venturing from our life-giving home to uncover the secrets of the cosmos and our own unimagined possibilities.